Okay, welcome back to Orthographic Projection Part 2. We're going to be adding a T-fitting into these drawings. So here we have a basic half-inch copper T. We can take a look at the three views of it. Let's say this is the front view, top view, and side view. You draw the front view like this because the T is really flat to you. You draw the side view like this, and finally the top view like this. What symbol would you use in the chart to draw the top view of this T? So we're going to look at this T in particular right here. Any ideas? The top view. Remember, ask yourself the three things. Is it coming towards me, going away? Is it flat to me? So there it is there. What symbol would you use in the chart to draw the front view of the T? So now you're standing here looking into this T. So is it coming towards me? Is it going away from me? Or is it flat to me? And there's your answer. It's coming towards you. So it's going to have a dot in the center of it. And what symbol would you use in the chart to draw the side view? So this T down here at the bottom. So you're here looking right directly onto it. The same symbol you use to draw the top view. Okay, it's the same thing. It's flat to the viewer, so that's how you would draw it. Let's draw the three views. Remember, top, front, and the side. So we're going to start with the front view of this. So if we're looking directly onto this drawing here, again, I like to start left to right. And it's your total preference, whatever you want to do. But the front view, what's this 90 doing? This 90 is going away from the viewer. Front view, what's this T doing? Well, the T is coming towards the viewer. From the front view, what's this 90 doing? Well, this 90 is flat to the viewer. And finally, this T down here, what's this T doing? It's going away from the viewer because you're over here looking at it. And the pipe is going the opposite direction. Okay. Would you see this pipe from the front view? No. Would you see this pipe from the front view? No. Would you see this pipe from the front view? Technically not, because you're going to be looking directly into it. Right? So, this is what the drawing looks like. It's a little pale to see it on here, but let me explain it. Here we have a 90 going away from the viewer. And all these little breaks in the lines, I don't know why it came across this way, but these are all solid lines, okay? There's no dashes in it like it's showing here. Here we have a T coming towards the viewer, right? So it's got the dot in the middle of it. We have a flat 90. And from the front view, we have a T going away from the viewer. Okay, what about the side view? Well, if we take a look at the side view, we'll be standing here looking at this. We have a flat T. We have a 90 going away from the viewer. Can't see this T, but we can see this line. Right? We can't see the 90 back here, but we can see this line and this hub. You want to take a shot at it? If you do, pause it, and then I'll pull up the slide here in a second, and we'll see how you do on it. So here's going to be the side view. So let me explain this here to you. Here we have a flat T to the viewer, which is right here. We can see this line here. Again, these are all solid lines. We have this line going up here to a 90 going away from the viewer. There's the 90. There's the drawing. It's just that we've dropped this line down to here. Okay, right here. So we established that we could see this line because there's nothing here blocking it from the side view, right? So we can see this, and it's at the same level as the 90, so it has to come off the side of the 90. And when you see the hub, there's the hub. This line also we can see because there's nothing here blocking our view. It's wide open. Okay, so with that, we can draw this line. It's at the same level as the 90, comes off the side of the 90. And we can see the hub right there. Okay, and finally the top view. Again, if you want to pause things, try and scratch it out, and then resume the video, and you can kind of see how you made out here. But this is the top view. So let's take a peek at this. Left to right. If we're up here looking down on this, we have a flat 90. Where's the flat 90? We have a flat T because it isn't coming up to us. It isn't going down. So it has to be flat. And there it is. We can see this line here, and it goes into a 90 going away from us because we're up here. It's turning down. There's a 90 going away from us. And because we're here looking, we can see this because it's not blocked, right? So here's that little line coming off what looks like the top of the 90, but it's actually further down. And we can see the hub. We cannot see this line from the side view. Or sorry, from the top view. So to actually see some drawings in orthographic, to see this and understand this, you need 3 views. Right? Because if you look at the top view, and you're like, okay, well the pipe comes here and this must be coming off the night. What kind of fitting is this? You think to yourself, and then you're like, okay, I think I'm going to have to go to a different view to see exactly what's going on. And then when you come to the side view, you can see that this pipe is down here. So it gives the whoever's reading the orthographic views a better understanding. So you always need those 3 views to see the one overall, the overall big picture, if you will. So let's talk about the side of the symbols. And let's first look at a 90 going away from the viewer. Neatness is important. Crisp lines are important when doing a proper drawing. So when you guys are drawing these, I expect these lines to be perfect. No smudges, no crappy looking erases and then just going over it. The pencil has to be sharp, and you have to be precise in what you're doing. Always use the architect scale for sizing these fittings. Here's a 1/4 inch, a very important scale that we use, okay, and that you'll use in architect readings and blueprinting. 1/4 inch and 1/8 inch are the 2 most popular scales used. We are going to pretty much focus entirely on the 1/4 inch scale. So these are called hubs. They are a 1/4 inch long. So that means this entire thing is a 1/4 inch. Okay, not half of it. The whole thing is this size here. So that would be the center, and you would put that on the center line. And then you would just take your line and go out to there, and then from there out to there, and that would make the whole thing. Now on a piece of paper, this is very small. Okay, so there's your 1/4 inch, the entire thing. The circle that represents the back of the elbow is generally a 1/4 inch as well. Now, if you don't have a circle template to actually make the circles with, you can just get a simple piece of paper that has 3 hole punch in it and rip out one of the corners with the hole in it, and it generally works quite well for this. Okay, so as a quick little to make your circles. The distance from the end of the line to the hub is also a 1/4 inch. And that line should extend into the center of the circle. Also notice this is not a closed circle, but it must remain broken when drawing the back view. So the circle doesn't close right in. There's no specific measurement for it. I just have to see a break in it. It doesn't touch the main line. This line can be any length. It depends on the isometric that you're copying. So this line here, if I say just draw a 90 going away from the viewer, this line can be any, you can stop it here, you can stop it here, here, whatever. What I'm looking for is positioning of the line in the center of the circle, that these are 1/4 of an inch long, and at this distance is 1/4 of an inch long as well. Okay, how about a 90 that's directed towards the viewer? So here we have a 1/4 inch circle with a dot in the center. Again, if you don't have a circle template to draw proper circles, you could just use a 3-hole punch piece of paper and use one of the holes in it. It'll get you through for this exercise, no problem. The dot in the center, it just has to be, don't make it a huge dot. You get the idea from the pictures, but there has to be a dot in there. There's no size to it. The distance from the dot to the hub, so from there to there, is 1/4 of an inch. All the other measurements are the same as the 90 directed away from the viewer. So 1/4 inch. 1/4 inch really is our magic number. So let's look at a T directed away from the viewer. Again, we have a 1/4 inch broken circle, and notice it does not touch the center line. So we have a broken circle, but it doesn't touch this center line going through it. Okay. Again, you could use the hole punch or a piece of paper with a hole punch for that line too. It's 1/4 inch from each hub to the center of the circle. Okay, so when you would draw this, you put your 1/4 inch measure here, and you would mark the line, put it here, mark the line, and then you'd make these 1/4 of an inch too. Okay, so from the center of the circle is 1/4 inch. Again, as with all symbols, the hubs are 1/4 inch as well in their total length. So let's look at a T directed towards the viewer. As with the 90, we have a 1/4 inch connected circle with a dot in the center. So with these, the circle is round, and the dot is in the center. Now these look like pretty crappy circles, I gotta admit. They look pretty rough. These pictures are blown up huge. Okay, when they're actually down to the proper scale size, they look a little normal. It's a 1/4 inch from each hub to the center of the dot. Okay, where the other one, when the T is going away from you, is from the center of the circle. Here's from the center of the dot. Again, as with all symbols, the hubs are 1/4 inch as well in their total length. Okay, all the hubs are 1/4 of an inch. Notice that the lines coming into the circle do not touch the circle. So they just break through the hub. This is the hub. The line just comes through, but it doesn't touch the circle. Okay, there's no measurement here. Just break the line and that's it. So let's look at an elbow or a T, the flat views I like to call them. Very simple to draw. The magic number is 1/4 of an inch. The hubs are 1/4 of an inch from the back of the 90 to the hub. 1/4 inch apart where the T meets at its center. The hubs are all 1/4 of an inch apart. So again, 1/4 of an inch is our magic number. The distance from here to here is 1/4 of an inch. From here to here is 1/4 of an inch. These are 1/4 of an inch. Both these hubs. From here to here is 1/4 of an inch. From here to here is 1/4 of an inch. And from here to here is 1/4 of an inch. Okay, and the hubs themselves are 1/4 of an inch each. So here's a little trick to help you remember some of these shapes and how to draw them. So imagine your classmate is in the hallway walking away from you. You see the back of their head. There's no eyeball, there's no eye contact. There's no dot in the middle of the circle, right? So here's your classmate walking away. You don't see their eyes, right? They're going away from you. You don't see their eyes. You see the back of their head. So this would be a 90 going away from you. If your classmate's walking towards you, then you would see their eyeball. So here they are, and you see their eyeball as they're walking towards you. This is the 90 coming towards the viewer. The same holds true with T's. With the T going away from you, it's a half broken circle with a line through the middle of it. There's no dot. When the T is coming towards you, it has a dot in the center of it. And that's it for orthographic projections part 2. We'll see you next time. Thanks so much.